In this video, we will apply the Bernoulli equation into an orifice. Orifice means that any opening of pipe or body. Okay, we will start with simple example here. Water is flowing from a garden hose. A child places his thumb to cover most of the hose outlet, causing a thin jet of high-speed water to emerge. The pressure in the hose just upstream of his thumb is around 400 kilopascal. So here we state that at this point 1 is the pressure is measured to be around 400 kPa. If the hose is held upward, what is the maximum height that the jet could achieve? So we need to find the distance here, which is hash. Okay, due to the loss of the energy from point 1 to point 2 means that the flow will stop at point 2 due to the gravity. So how we want to get the value of hash? Here we need to do some assumption and based on the Bernoulli equation. So here, if we check at the time of this, we need to look at point 1 and also just exit of his thumb. What we will see is that the huge difference of velocity. If you look here at point 1, the velocity is quite higher as compared to, the velocity is quite lower compared to Vj due to the difference of area. For example, I just put some value here to make you understand the rationale of this assumption. For example, here initially the velocity is around 5 meter per second at point 1, but when we put the thumb here, the exit velocity here will be much larger than 5 meter per second. For example, it can becomes 100 meter per second, and due to this difference of velocity and it is too much difference, we can neglect V1 in term of Vj, and in our assumption of the Bernoulli equation, we will assume that V1 will almost equal to 0 because of this huge difference of velocity. So when we write out the Bernoulli equation, P1 over rho g plus V1 square over 2g plus Z1 equal to P2 over rho g plus V2 square over 2g plus Z2. Okay, where is this V equal to 0? At the point 1 here, just before the flow come up from the thumb. Okay, this is very important assumption in order to get the Bernoulli equation is applicable. And then we need to know that the pressure at point 2 is exposed to the atmosphere we can also neglect this as 0 kPa based on the gauge pressure at the atmospheric level. So here, what is the left term? We will simplify at v2 square over 2g. Okay, and then also we have, sorry, I will make pressure first, P1 over rho g minus V2 square over 2g equal to Z2 minus Z1. So here you know that the difference of Z2 and also Z1 is your hash, so that your hash equal to P1 over rho g minus V2 square over 2g. Okay, but in this case V2 is the stagnation point of this flow, because the flow is stopped at point 2, means that this is equal to 0. Now your equation becomes more simple. This is equal to P1 over rho g, which we know that P1 from that example state that the value is 400 kPa, divided by the density of that water, which is 1000 kg per meter cube, then multiply with the gravity acceleration, we will get the height as 40.77 meter. Okay, so if the pressure at the thumb of this child is 400 kPa, it will create a huge distance upward, which is equal to 40 meter. That is the some idea on how orifice works. Next video will go for the next type of orifice on the body of the pipe or tank.